Hello friends, welcome to my channel. Our today's video is about radiography test film interpretation. So in this video I'll explain how the weld defects are identified from radiography films. So basically this is part 2 of our RTFI video. I have already made part 1 and in part 1 I have explained some defects, and in this part I'll explain the remaining defects. So in part 1 I had explained how to identify lack of penetration, offset, lack of fusion, porosity and excess penetration. So these 5 defects I had explained in part 1. Now in this video, in the present video, I'll explain the remaining defects. These remaining defects I'll explain in today's video, that is undercut, slag inclusion, tungsten inclusion, external concavity, internal concavity, burn through, cracks, and finally I'll explain spatters. So before starting this video, let me give you a brief introduction of myself. My name is Sandeep Anand. I am a mechanical engineer and I am having 14 plus years of working experience, and my hobby is to share my knowledge through my website, that is weldingandt.com. So my website is weldingandt.com, and the second mode through which I share my knowledge is my YouTube channel. This is youtube.com/weldingandt. So friends, you can financially support my initiative by joining my channel. See, after subscribing my channel, you will see a join option, a join icon. By pressing this join icon, you will be able to support me financially. So please join my channel and become a member of my channel. So in my part 1, in the part 1 of this video, I had already explained lack of penetration. These are the lack of penetration, mismatch high-low, then lack of fusion, then porosity. I had explained the different types of porosity like scattered porosity, cluster porosity, wormhole porosity, elongated cavity. So I had explained all these in part 1 of this video. So these are the porosities. This is hollow bed, this is wormholes. Then finally I had explained excess penetration in the part 1 of this video. So now in this part we'll start with undercut, how to identify undercut. So undercut will appear as a dark line on a radiography film, dark black line on a radiography film, and the location will be along the edge of the weld. First see this photo. So I've taken this photograph from my website weldingandt.com. So these are the undercuts. You can see undercut is nothing but a groove which is formed on the parent metal near weld metal. See here you can see the groove. Here you can see, can you see this groove? So this groove has been formed, and this groove has been formed on the parent metal but near to weld metal. So this groove is known as undercut. Here in the second photo also you can see undercut. So here can you see this undercut? This undercut is nothing but a groove. So how undercuts can be interpreted or identified on a radiography film? Here, if there will be undercut, you will see a very dark line along the edge of this weld. See here, this is the edge of the weld, and at the edge you can see this dark line. So this dark line is nothing but the undercut. In the second photograph also you can see there is undercut at the top, and here you can see the undercut. This undercut is till the last of this film. So this dark line at the edge of the weld is nothing but the undercut. Now friends, I would like to ask you a question. Can you see a dark spot over here? So this is my question to you. Can you recognize what kind of defect is this? Whether it is a defect or not? And if it is a defect, you please give the answer, what defect is this? You can guess, or you can, if you don't know, please write that I don't know what kind of defect is this. So this is my first question to you. Now undercut, yes, see undercut can be formed on external side as well as internal side. just for example, here you can see this is the front side of the welding. So this undercut has been formed on the front side of the welding. So this will be known as external undercut. Now what will be internal undercut? Just for example, please take this photograph. Don't see this excess penetration. Just I want to show you. Here, if the undercut is formed here, it will be known as external undercut. Means it will be formed either here or here. Then this will be known as external undercut. But if the undercut has been formed on the root side, like here, on the back side of the welding, then this type of undercut will be known as internal undercut. So internal undercut will appear at the root run, at the edge of the root run. So here in this photo, you can recognize this portion is the root portion, root run. Okay, and on the root run, here you can see this dark line. So this dark line is nothing but the undercut. Now you can ask a question that lack of fusion also occurs at this edge only. So how we can differentiate with that? See friends, lack of fusion will always occur in a very straight line, But here you can see, let me erase the red dots, then you will be. But here you can see that this dark line is not straight. Hence it is an internal undercut. So like this you can differentiate between undercut and lack of fusion. Lack of fusion will be a very straight line. However, internal undercut will not be a straight line. You can see very clearly this is not straight. Now our next defect is slag inclusion. See, slag inclusions are very irregular shaped dark spots. So you will see dark spot and it will be irregular shape. As I had explained in porosity is a dark spot, but it will have rounded contours. But slag inclusion spots will be very irregularly shaped. It can be slightly elongated also, and it can occur anywhere on the weld at any space. These are unevenly spaced. In slag inclusion, there is one variant or one type, that is elongated slag lines, that is also known as wagon tracks or tram lines. So tram lines or wagon tracks are nothing but elongated slag lines. These are elongated or long slag lines, and it appears as a single or parallel dark lines. But please remember that this will not be a straight line. Now see here, this irregularly shaped dark spot is nothing but the slag inclusion. This is a slag inclusion, this is also slag inclusion. These are irregular shaped dark spots. Now in this picture here you can see this is irregularly shaped dark spot. So this is a slag inclusion. Now friends, I will ask you a question. Can you see this defect? So this is my question number 2 for today. What defect is this? Is it a slag inclusion or is it a porosity? So friends, if you have forgot, please watch my radiography film interpretation part 1 video. There I have explained how a porosity look like. So after watching that video, please give this answer number 2, whether it is a porosity or it is a slag inclusion. Now here, as I told you, the wagon tracks are nothing but elongated slag lines. So here you can see the wagon tracks. These are nothing but the slag, but in elongated form. So these are wagon tracks. Now tungsten inclusion. See, sometimes in TIG welding, the tungsten electrode get stuck into the molten weld peel, and that forms the tungsten inclusion. These are very irregular shaped and bright spot. It looks very bright, white and bright, and these are usually very small, means almost 0.5 to 1 mm. It will look very small bright spots, and it can appear anywhere on the weld. Here you can see this bright spot. This is tungsten welding, tungsten inclusion, this is tungsten inclusion, this is tungsten inclusion, this is tungsten inclusion. So here you can see all the bright spots are nothing but the tungsten inclusion. This is very easy to recognize. Now external concavity. So I'll show you a photograph of external concavity. See, here you can see the concavity in the welding. So this is nothing but the concavity, right? See, a normal welding look like, this. A normal welding will look in this shape. Sorry, let me draw one more time. How a normal welding will look. I know you people know, but let me show you one. This is very difficult, to draw, but I'll try one more time. See, a normal welding will look like this. Means it will be above the parent metal and the shape will be sometimes like this curved type. But when it becomes in concave shape, then it will be called as external concavity. If the welding has become in concave shape, then that will be called as external concavity. There is a term internal concavity also. When this concavity will be at the bottom side, then that will be called as internal concavity. So that also I will explain in later slides. But first let me explain you the external concavity. Okay, so external concavity will look very dark, and the entire welding will look dark wherever there is external concavity. So the entire welding will look dark in external concavity. Yes, there is one more term, underfill. See, underfill, what is underfill? Underfill is when the weld metal remains below the parent metal. If the welding is below the parent metal, normally welding should go above the parent metal, but when welding is below the parent metal, then that is called as underfill. And underfill will also look like this only. Means entire weld will be look very dark. See, again this photo I have taken from my website weldingandentity.com, and from this photo you can see this underfill. You can see the weld metal level is down from the parent metal. In this photo also the weld metal level is down. In this photo also you can easily see this weld metal level is down from the parent metal. So this is underfill. Now internal concavity. There is two terms. One is internal concavity and second one is burn through. These two are very different terms, but I have taken in one slide because the burn through is a spot like defect. Spot at one place there will be a burn through, and internal concavity will be at some length, will have some length. So burn through will be on a spot, at a spot, but internal concavity will have some length. See, internal concavity, means concavity at the root side will be known as internal concavity. So if there is a burn through will be at a spot, but if there is a internal concavity, this will go up to some length in the welding. Up to some length means, suppose if your welding is like this, so if suppose this is the welding, then this internal concavity will go up to some length. So it is internal concavity is elongated, irregular, darker image, and it will appear at the center of the weld. Why it will appear? Because just a second. It will, because this is the radiography film. Up to this weld, all area will be displayed on the radiography film, and since there is this concavity, so this area, root area, will be appear dark on a radiography film. And burn through is the diffraction or crater type hole, but it is not elongated. It is not elongated, but it appears it forms at a spot. So this is how burn through looks. At the center of the welding, there will be a darker image. So this will be called as this will be called as internal concavity or suck back, because this is elongated. Again, here in this diagram you can see there is at one spot this dark spot is there. So this is burn through. Now cracks is the most dangerous defect, and there are many types of cracks, but I've taken two types, that is transverse crack and longitudinal cracks, because these are the this is how mainly cracks are classified. So transverse cracks will appear as a dark line across the weld, and longitudinal cracks will appear as a dark line along the length of the weld. So transverse will be across and longitudinal will be along the length. Here, as you can see, this transverse crack is across the length of the weld, and it will appear on a radiography film like this: dark line, transverse across the see, length of the weld is in this direction, so this is across means this type, across the length of the weld. This is transverse crack. Now longitudinal crack, you can see this is the longitudinal crack, this is along the length of the weld. So this is at the entire radiograph there is a crack. So this is how cracks can be identified. Now spatters are small droplets of welding which are splashed during the welding. So this appear as a light spot. It will appear as a light spot, and it can appear anywhere on the weld and adjacent to the weld, on the parent metal also. This is how spatters will appear. So there are many spatters, you can see. This is how spatters will appear. There are many spatters. So friends, with the spatters I'll conclude this video, and I had asked some questions from you during this video, so I'll expect that you will answer my questions, and you will write the answer in the comment box of my video. So friends, thank you very much for watching this video. Keep sharing my videos with your friends, with your colleagues, and it's time to say goodbye.